Hi, my name is Josh Twist and I work on the Windows Azure Mobile Services team. A few weeks ago we announced support for iOS developers building native Objective-C applications for their iOS devices with Windows Azure Mobile Services, and that made it very easy for iOS devs to access structured storage and our easy authentication story. Today, I'm really excited to announce that we've rounded out our support for iOS with some improvements to the SDK, but most importantly, with the ability to send push notifications via APNS to your iOS applications. So now, I want to do a quick tour of those features and show you what it's like to use mobile services and just how easy it is to add the power of Windows Azure to your iOS apps. So let's take a look at a demo. Here I am in the Windows Azure portal, and signing up for a Windows Azure account is incredibly easy. Just go to windowsazure.com, sign up for the free trial, and you get 10 free mobile services. Once you're in, you can create a new mobile service by clicking New, Compute, Mobile Service, Create, and then enter the name of your mobile service. I'm going to call this iOS Demo 1. And I'm going to connect to an existing SQL database to store my data, so I'm just entering the credentials there. And that's going to start the provisioning process, which will create my runtime, it'll set up my database, and give me an internet address point, which will be the endpoint for my service. And we're done. OK, so if I click on the name, I'll be greeted by our Quick Start, which lists all of the platforms that we support, including iOS, and it's a short guide that helps me get my app connected. So I'm going to follow this guide here, which is going to help me create a new iOS application, and it's going to help me build a to-do list app. And the first part of any to-do list app is to create a table to store your to-do list items. So I'm going to click that to create the table right here, and then I can start downloading my personalized starter project. And this project has actually been bootstrapped to include the code that's going to connect to my mobile service. So I'm going to open this up, and you can see I have an Xcode project here. And what I want you to notice about this project is it actually contains already the code to connect to my service. So there's my URL, and there's my application key. So this is actually good to go. We're ready to run now. So I'm going to run this application in the simulator and start working with data. So the first thing I'm going to do is insert a new item, Hello iOS World. And that's going to actually save data to Windows Azure Mobile Services. And to prove that to you, I'm going to switch back to the portal, go to the Data tab here, and we can browse this data. And here you can see is my text, Hello iOS World, which I just inserted. So working with data, doing queries, inserts, deletes, updates, etc., is super easy with Windows Azure Mobile Services. Now, I just showed you how to connect a new app using our tutorial. What if I have an existing application I want to connect? So here's an application I've been working on, and it's called We're the Friend. And it's a simple location check-in application. And I've almost finished it, but there's a couple of steps remaining. I have to add my client instance here, and I also have to query the check-in data. So let's go and do that now. So I switch back to the portal. You'll see I already created a mobile service for this. Here we are. So I click on that. And then I go down to my Quick Start, and I'm going to follow the flow that allows me to connect an existing iOS application. Open this up. Now, it has all the instructions for referencing our SDK. I've already done this. So what I need is this code here that contains my application key and URL. And I can copy that to the clipboard, switch back to Xcode, and just paste this in right here. And so we're almost done. What I now need to do is start reading data from a table. So I'm going to create a table instance. I do that by calling getTable with the name of the table I want to read data from. In this case, we call the table check-ins, because I'm going to read all the check-in data. Now here, I can call table read, and you'll see we have a variety of methods here that allow me to load data specifying an NS predicate, which is a way of specifying a query that will execute on the server in the database. In this case, I just want to read everything, so I'm going to call read with completion. And I've got a block here that will be called when the operation's finished, and I have my data. And I just call completion now and pass in those items. And that will be displayed in the UI. So we're actually good to run this now. So I'm going to run this in the simulator. Wait for that to load. Here it comes. Let me make this a little bit smaller so it fits on screen. Now notice what's actually happening here is the application is logging me in. So we have support for authenticating your users via Facebook, Twitter, Google and Microsoft account, and it's just a single line of code to do that. So I've already put that code into my application, and the service is now aware of my identity as a user. You can see on screen now, I can see all the recent check-ins from people I know, including this check-in here from Scott, who I work for. Now, I can also go and find friends, so let's see who's in the system. So a few people here I know, and I can actually send a friend request to myself, so I'm going to do that. And then I can look at my friend requests, and lo and behold, there's that friend request which I can approve or reject. I'm going to approve that, as I have no other friends. And I can also make a check-in, so I can say hello world here, and this will appear in the recent check-ins collection. So super easy to get working. This is all just using those data operations that I showed you before in the quick start. Now, there's one problem with this at the moment, and that is that I don't have a friend relationship with Scott here, so I shouldn't be able to see his data. And I could naively implement security in the client application. However, that would be subject to someone jailbreaking a device or just using some protocol inspector to change the packets going over the wire. Instead, I need to implement that security on the server. And I can do that easily with scripts in mobile services. So I'm just going to switch over to my portal now and find the data table that contains check-ins, and then go to the script tab. So here I can write JavaScript that executes securely on the server whenever data is being inserted, updated, deleted, or read. In this case, I want to provide security for queries, so I'm going to change the read, and I've got a script that I prepared earlier, and that is here. So let me copy this, paste that into the portal. Let me explain what this is doing. This is actually going to augment the incoming query and add an additional predicate that says, allow the user to perform any query, but make sure he only gets records from his own friendship group. So I'm going to save this, and that should deploy live to Windows Azure in just a few seconds. And that's now live in Windows Azure. So I go back here, I'm going to click refresh, and you should see that Scott's data has disappeared. And that's because we've implemented that security on the server to make sure I can only see records from my own friends. Now, wouldn't it be cool if when I did a check-in, I sent a push notification via APNS to all of my friends, in this case me. So what I'm going to do is add a script that runs on the server whenever data is inserted to the check-ins table. Now here's a script I prepared earlier for that as well. So I'm going to paste this in. And let me explain this to you. What this is going to do, when an insert is happening, I get three pieces of data. I get an item, which is the item being inserted, the user, which is the person performing the operation. I can trust this data because it's been authenticated by mobile services, and the request, which allows me to control the flow of execution. So here we call request.execute, which says go ahead and insert that data into the database. I then specify a callback, which will be invoked here before the data is returned to the user, but after the data has been inserted into the database. And then I call request.respond, because I actually want to get that response back to the client as quickly as possible. Then I run some SQL against our SQL database to find all the friends of the current user that's performing the check-in, and most importantly, find the device token so I can send that push notification. I then execute that query and iterate over the results, calling this API, and this is the key thing. So this is just a single call here to send a push notification via Apple's APNS servers. So I call push.apns.send, I specify the device token, and here you can see I'm specifying an alert, which is the payload for a toast notification that will arrive on the device. So I'm going to save this. And I've already configured, done my iOS provisioning to set up my application, and I've uploaded on our push tab, so let me show you this here, I've already uploaded my development certificate. So now our mobile service is capable of talking to APNS in a secure way. So we're pretty much good to go. What I now need to do is deploy this application to my actual iPad so I can receive a push notification. So I've got my iPad here. I'm going to deploy that now. And so that you guys can see this, I'm actually running a very cool app called Reflection. that allows me to display my iPad screen on the screen here. So here you'll see we're logging in. I'm logged in as me via Twitter, and you can see I can only see my own data. Now, what I want to do is actually exit this application, because now I can receive toast notifications, and in the emulator, I'm going to perform a check-in. The bit of luck, that'll arrive on my iPad device here. Let's try that now. Testing. And there you go. So you can see just how easy it is to start using push notifications, structured storage, and even authentication using Windows Azure Mobile Services and its support for iOS.